Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about how we use the Business Analyst calculator to do our different calculations for ordinary simple annuities. We're going to be taking a look at using these white functions on your Business Analyst calculator, which are the time, value, money functions. And we can use these to find any one of these values if we know the other values. So let's go through a series of examples to show how we do that. Our first example says you are 20 years old and invest $250 at the end of each month until you are 65 years old. Find future value if a fixed interest rate of 9% compounded monthly is possible. We know that this is an ordinary simple annuity. First of all, because it's regular payments, equal payments at regular intervals. Then we know it's an ordinary annuity because we're making payments at the end of the interval, at the end of each month. We know it's a simple annuity because our payments are made at the end of each month, which means there's 12 payments in a year. And our interest is compounded monthly, so our number of compound periods per year is also 12. The number of payments per year is 12, and the number of compound periods per year is 12. Now let's fill out the values that we know. For N, it's 12 times a year times the number of years. And from 20 years old to 65 years old is 45. Interest rate per year is 9%, and we leave it as a percent, so just put 9. Don't change it to a decimal. The payments are $250, so you're making the payments of $250. They're going out of your pocket, so we're going to put a negative. Present value, there's no other money that's in that account, so the present value at the start is 0. And we want to find future value. So let's take a look at how we use our calculator to do that. First of all, anytime you're doing time, value, money questions, make sure you clear any work that may be in there from previous questions. In order to clear it, you have CLR TVM. That's a second function of future value. So go second function, future value, and that will clear any other values that may be in there. Next, you want to enter the payments per year and the compound periods per year. So in order to do that, it's P per Y is above the I per Y. So you go second function, P per Y, and you're going to enter 12. So we're going to put 12 and make sure you enter it. Then you either scroll up or down, and you'll find compound periods per year. It automatically changes to the same value as payments per year, so it's 12, but it doesn't hurt to check it. So those values are good. We're going to quit this, so we're going to go second function, quit. Now we're going to enter these values. So 12 times 45 equals, and put that in for N. Then I per Y, we're going to enter 9, and then press I per Y. Payment is 250, so 250, and to make it negative, we press this change sign key, and we put that in for payment. Present value is 0. It should automatically be 0 if you've done the clear, but if you're not sure, you can always put 0 and put that for PV. Now we want to know what future value is, so we use our compute function, compute future value. So the future value of this annuity is $1,851,219.62. Before we start our next example, let's clear everything. So I'm going to start by clearing the display, but I also need to clear the time, value, money values that have been put in. So second function, clear. Okay, let's take a look at the next example. It says you need $20,000 in 5 years for a trip. How much should you set aside at the end of each month to have sufficient funds if your investment earns 8% compounded monthly? So end of the term, it's an ordinary annuity, and you're making monthly payments, and the interest is compounded monthly. So payments per year and compound periods per year are both 12. They're equal. Therefore, it's a simple annuity. N is the number of payments. You're making 12 payments per year for 5 years, so 60 payments. The interest rate per year is 8. The payment, you don't know that. That's what you're finding. Present value is 0. We're not starting with anything in that account. And the future value, we want it to be worth $20,000. Starting with payments per year and compound periods per year, let's check that. So second function, payments per year. Notice it stayed the same from our last example. If we scroll, that stayed the same. So we're just going to quit. We don't need to change that. And now we're going to put these values in. So the number goes in first and then the function. So n equals 60. Interest rate is 8, so 8 I per y. Payment we don't know. Present value, it should be 0 because we've cleared everything, but if you're not sure, you can always put it in. And future value is 20,000. Now we want to compute payment. So compute payment, and it is negative because you're going to be putting that money in. We can ignore the negative. It's $272.19. Again, clear the display and clear the worksheet before doing the next example. Our third question says, how much money do you need to invest now to generate a cash flow of $12,000 at the end of each year for the next 10 years, given an interest rate of 7.5% compounded annually? So in this case, our payments are once a year and our compound periods are once a year. N is 10 years, one time a year for 10 years is just 10. Interest rate is 7.5. Payments are $12,000. We want to know present value. We want to know how much do we invest now to generate $12,000 per year for the next 10 years. And future value is 0. Let's start with P per Y and C per Y. So second function, P per Y, it's 12. We want to change it to 1. Make sure you enter. When we change that to 1, automatically C per Y changes to 1. So now we're going to quit and put our values in. 10, N. 7.5 is Y per I. Payments of 12,000. In this case, 12,000 is going to be positive because you're going to be receiving that money. So it's coming to you, it will be positive. Present value is what we're asked to find. So let's compute present value. And we get $82,368.97. It says negative because you're going to be investing that. It's going into that account, but we can ignore the negative when we give our result. Let's clear this and clear our worksheet and take a look at the next example. Sam has $25,000 in an investment. He contributes $3,000 at the end of each year for 4 years. How much is the investment worth at the end of 4 years if he is earning 5% compounded annually? So in this example, we have a present value of $25,000 as well as payments, and we want to know future value. Let's start with payments per year. It's 1 per year. Compound periods per year is also 1. N is number of payments, which is once a year for 4 years, so that will be 4. Interest rate is 5. Payment amount is negative 3,000. Present value is negative 25,000. That money went into an account. And we want to calculate future value. Let's start with payments per year is 1. Compound periods per year is also 1, so we can quit and enter our values. N is 4. Interest rate is 5, I per Y. Payment is negative 3,000, so change sign. That's our payment amount. Present value is negative 25,000, so change sign, present value. And now let's compute future value. So the future value of that investment that started off as 25,000 and then included these additional payments will be $43,318.03. Let's clear the display and clear TVM. Our next example says you deposit $1,200 at the end of each year into an annuity that pays 6% compounded annually. When is the future value equal to $6,764.51? So let's start with payments per year. It's at the end of each year, so that's just 1 payment per year. The compound periods per year is just 1 because it's compounded annually. N is what we're finding, and when we get a value, it will be in years. N represents the number of payment periods, and if there's just 1 per year, then that'll automatically be years. Interest rate is 6%. Payment amount is negative 1,200. Present value is 0. And future value is $6,764.51. So let's start. Payment per year is 1. Compound period per year is 1. We're good. Quit. Now, and we don't know. So let's enter our interest rate as 6. Payment is $1,200, and we can make it negative. So change sign, payment. Present value is 0. It should be 0 since we cleared this, so we don't need to enter it. And future value is $6,764.51 for future value. Now let's compute N. And we get 4.999 and so on, which we can round off to 5 years. Just be aware that if our payments had been monthly and compound periods had been monthly, when we got N, that would be the number of months. So then you could change it to years by dividing by 12. Clear TVM and do one last example, and this time we're going to find interest rate. So in our last example, it says Mary borrowed $14,064.67 for a car purchase. She has to make 48 monthly payments of $350. What interest rate compounded monthly is she paying? We can assume that her payments start a month after she borrows the money, so at the end of the interval period, and their monthly payments, so their payments per year would be 12. If the interest rate is compounded monthly, then she has 12 compound periods per year. N would be 48. She's making 48 payments. Interest rate is what we're finding. The payment amount is $350. We make that negative. Present value is what she borrowed, so $14,064.67. Future value is 0. Once she's paid off the loan, there's nothing left. So let's start off with payments per year and compound periods per year. Second function, P per Y, is 12. Make sure you enter it. Scroll to make sure compound periods per year is also 12, and then we can quit. Now we can plug in our values, 48 for N, 350, make it negative for payment, and $14,064.67 for present value. And now let's calculate interest rate. Compute interest rate, 9%. You now know how to find any of these values as long as you know all the other values. Just be careful to clear before each question and to check your number of payments per year and your number of compound periods per year.